Hi, dear students. Welcome back to the B.Sc. third year class of Analytical Chemistry. In yesterday's lecture, we have learned about the different types of sampling of substances and sample cells. In today's lecture, we are going to learn about the IR detectors. So, let's start with this IR detectors. The measurement of infrared radiation is difficult as a result of the low intensity of the available sources and the low energy of the infrared photon. What is the measurement of infrared radiation is difficult because due to the low intensity of the available sources and the low energy of the infrared photon. It is usually the detector system that limits the sensitivity and precision of an infrared instrument. Due to what? The infrared detector limits the sensitivity and precision of an IR instrument due to the low intensity. The convenient phototubes The convenient phototubes are generally not applicable in infrared radiations because the photons in this region lack energy to cause photo emission of electrons. So here what we cannot use the phototube you have used in the B.Sc.III, that is UV visible spectrophotometer, but here we cannot use the phototube because here phototubes emit the photo electrons. The thermal detectors whose responses depend upon the heating effect of radiation can be employed. So here we are having the option, that is the alternative, that is the thermal detector. With these devices, the radiation is absorbed by the small black body and the resultant temperature increases is measured. So it is the device is coupled with the black body, or it is associated with black body, and it absorb radiation, and the increase in temperature is results to, and this increase in temperature is measured by means of detector. So to obtain a maximum temperature increase, every effort is made to minimize the size and thickness of the absorbing element and to concentrate the entire infrared beam on the surface. So for the increasing temperature, we made efforts to focus the radiation, beam of radiation on the surface by decreasing the size or minimum thickness, or maintaining the thickness. So the temperature changes are confined to a few thousands of degrees Celsius. What is this? The temperature is confined is about few degrees of Celsius. The problem of measuring infrared radiation by thermal means is compounded by thermal effect from the surrounding. So what is the principle of measurement? That is thermal measurement. It is the temperature change in the surrounding. So change in temperature effect from the surrounding. The absorbing element is housed in a vacuum and carefully shielded from the thermal radiation emitted by other nearby objects. So in this, the absorbing element is housed, means it is get fixed in the vacuum and carefully the element the shielded from the thermal radiation emitted. So emission of thermal radiation is protected by housing the element in the vacuum. So the various types of detectors used in IR spectroscopy are some, that is what the first is. One is the bolometers. A bolometer is a type of resistance thermometer constructed of strips of metal such as platinum or nickel, the resistance of which increases approximately, that is 0.4% for every degree Celsius increase in temperature. Here what the principle is, that what is bolometer? Bolometer is the type of resistance thermometer. What is the principle of construction? It is what constructed of strips of metal, means what, it is made up from the strips of metal, as a platinum or nickel metal is used, and the resistance of which increases approximately 0.4% for each every degree Celsius increase in temperature. If we increase the 1 degree Celsius temperature, then there is what, 0.4% increase in the resistance takes place with increase in temperature. So this is about the bolometer. So this see how this bolometer circuit looks like. It contains the resistance, that is, so it is the resistance. So basic bolometer bridge circuit is there, one battery is there, and one measuring. So that is what the current measuring device is there. So a bolometer function by changing resistance when heated. So it changes resistance when heated, means what, with change in the temperature, it what the increase in resistance is about 0.4% takes place. So the bolometer function by changing resistance when heated, it is constructed of strip of metal such as platinum, germanium or nickel, or from a semiconductor, that is what thermistor. The relatively large change in the resistance as a function of temperature is resulted. So large change in the resistance is due to the function large response time. So we what we have to change the temperature more. So rarely used in mid IR as IR transducer. So it is not used, it is rarely used in mid IR. So IR range of G bolometer is 5 to 400 centimeter inverse, that is what nearly about what 2000 to 25 millimeter. This is about what bolometer. The next one is the what thermistor. Thermistor is made up of fused mixture of metal oxides. So this thermistor is made up from the fused mixture of the what oxides. As the temperature of the mixture increases, its electrical resistance decreases, as what it is opposed to the bolometer. This relationship between the temperature and electrical resistance allows thermistor to be used as a IR detector in the same way as a bolometer. The thermistor typically changes resistance by about 5% per degree Celsius. It is response time is response time is low. So what is the thermistor? Thermistor is made up from the mixture of oxides, that is metal oxide, nickel, cobalt, manganese. As the temperature of mixture increases, its electrical resistance decreases. It is what opposite to the bolometer. In bolometer, there is a rise in temperature, that is what 0.4% increase in the resistance is also there. So it is directly temperature is directly proportional to the resistance, but here what the temperature is inversely proportional to resistance. If you rise the temperature of mixture, then electrical resistance get decreased. This relationship between the temperature and electrical resistance is useful to the what thermistor use as an IR detector. So as like a bolometer, the thermistor typically changes resistance about 5% per degree Celsius. Means what, 1 degree in there is a increase in temperature by 1 degree Celsius, then there is decrease in the resistance by 5%. So its response time is a slow. So what is the thermistor? Thermistor are the devices that have an electric resistance that is higher temperature dependent. Means what? The resistance is what? The higher temperature dependent. The material used in the thermistor are sintered oxides of cobalt, manganese and nickel. So it is mixed oxides. So constant potential is applied across the thermistor, and the difference in the current flow between the illuminated thermistor and non-illuminated thermistor is measured using differential operational amplifier. So what is the constant potential is applied after the thermistor, and the difference in current flow between the illuminated thermistor and non-illuminated thermistor is measured using a differential operational amplifier. So as the temperature of the mixture increases, its electrical resistance decreases. So as the temperature increases, electrical resistance decreases. Response time is what? 80 meter per second. Sorry, 80 meter per second, and it should be operate at a frequency less than what? 12 hertz. This is about the thermistor. Then thermocouple. Next detector is what? The thermocouple. The thermocouple detector is based upon the fact that an electric current will flow when two dissimilar metal wires are connected together at both ends, and a temperature difference exists between the two ends. Thus, the end exposed to the infrared radiation is called the hot junction, and in order to increase the energy gathering efficiency, it is usually a black body. So the another connection, that is the cold junction, is thermally insulated and carefully screened from the stray light. So the electric current what flows is directly proportional to the temperature difference between the two concentrations. So two connections or two ends. The junction for the infrared detection is formed from the very fine wires of such metals as a platinum and silver, or antimony and bismuth. So a well designed thermocouple detector is capable of responding to a temperature difference of about 10 to the power minus 6 degrees Celsius. So what is thermocouple? Thermocouple is a thermally dependent detector. Means what? Thermocouple is what? Thermocouple detector is made up from the two dissimilar metal wires and are what? Connected together at both ends, and a temperature difference exists between the two ends. Means what? They are connected with each other, and at the two ends the temperature difference is there. Means what? One is a hot end, that end is known as a what? Hot junction, that is which is exposed to the IR radiation. It is usually black body, because what is the purpose of making black body? To what? Get a more energy, that is what? Energy gathering is there. So hot junction is preferably used as a black body, while the other junction is cold junction, which is insulated and carefully screened from the stray light. Means what? It is what? Insulated and what? It is carefully screened from the stray light. Means what? The stray light or infrared radiation cannot fall on this end. The electric current which flows is directly proportional to the temperature difference between the two connections or two ends. So whatever the current flows through it is directly proportional to the temperature difference in between two junctions. The junction for the infrared detection is formed from very fine wires such as what? Metal, platinum or silver. So for making a thermocouple, we use the platinum and silver metal. So such platinum and silver metal are antimony and bismuth. So a well-designed thermocouple detector is capable of responding to temperature difference of about 10 to the power minus 6 degree Celsius. Then we see how this thermocouple looks like. This is what the measuring junction, hot junction, and heat is source. That is what this hot junction is continuously heated by means of heating. It is what it is the candle or any source of heat, and here is the voltmeter which is used to measure the current, and this is all the voltmeter. It is used to measure the potential, and here reference junction, that is what the cold junction, and it is what protected from the daylight, and here what hot junction and cold junction. This potential difference exists due to the